I'm going to show you the basic garment setup in this video, and I'm going to skip it in other pieces of garment so that we don't have to reiterate and go over things over and over again, because it's basically the same throughout, and I will only go over the differences in various other garments with buttons, belts, etc. I'm going to begin with the shirt because it's very simple. The problem with the shirt in general here is that we have long rectangles in some locations, and we have super high density in the collar and other areas. So I want to create a single-sided mesh for this that I will use to point deform this later on. In order to get this to work, the first thing we have to do is convert this to polygons. If you look at inside the geometry spreadsheet here, you'll see there's only one primitive right now, but there are actually quite a few. So you have to add a convert node. That's the very first thing. Leave it with the default settings that it has, and now you will see that we actually have all of these here. And that is the path attribute that you need to reassemble this later. Okay, next we will do a time shift. What we want to have is a branch of this deformation that we create that is set at the start frame that doesn't move, so we can create our deformable mesh, our cloth mesh. So put your cursor here, hit Alt-E, and change it to F-start, and accept. Next we're going to lay a point deformer down. This is what's going to move our sim mesh. So on the far left side we'll create a null here to indicate the far left channel, which will be our sim mesh. We'll call it sim mesh. And in the middle we'll have a rest state. This will be the output of the time shift. This has to have the same point count as the moving mesh that came from the original high-res shirt here. So we turn it on here and we should be able to see the mesh move. We should see everything should move just fine. Down this chain right here, this is a rest state chain. So if I click this and move forward, nothing will change. So we are in a rest state. This is the branch right here that we will use to create our sim mesh. We will remesh it, but first we have to chop it and make it a single-sided mesh to begin with. And we also want to put all of our attributes, paint attributes, any float values that we want to put on here, we want to put on a single paint attribute node. So we're going to go ahead and do this node and say paint attribute paint. So we're going to put that in this chain here. Okay. The next step is to create a single-sided mesh. I will start by separating this mesh with various selection methods. So clicking on an edge like this should loop all the way around. Control-Shift-2 will convert it to points, and then I'll hit a delete, which should blast that away initially here. I will go ahead and do this for the entire shirt until I get a single-sided shirt. Okay, I've completed creating a one-sided shirt. I went through and cut a bunch of pieces on this piece of geometry. Slowly but surely. Now this gets kind of messy and it gets kind of bulky here, so what I usually like to do is grab everything that I used for cuts and create a subnetwork out of it and just call it cuts. So this will be undershirt cuts. Let's see, and then this will be the piece of geometry that we're deforming. So now if we selected our point deform and just scrub the timeline, we should see it is moving our single-sided mesh along. The next step is to add a remesh node. Remesh. Oops. And we will adjust values until we get something we like. That might work. For this demo, we're going to go ahead and leave it at that. In the next video, I will go through and improve this entire setup for the shirt, but this is part of the basic setup. So now, if we were to look at this, we would see that we have a triangulated mesh that seems more even, that's following along with animation, which will give us what we want initially. One thing that's important to know, whenever you use a remesh node, be sure and put a polydoctor node after that. This will clean up any weird triangles, any floaty triangles. We want to set these to repair, repair, and ignore. Usually that gives me the best values, and leaving it at default size just as it is. So now we have a slightly different point count and little edges, points, triangles that were on the, you can kind of see we still have a triangle here and there that we're going to have to fix. So we'll do some adjustment to these values to see if we can actually get a better. But I'm not going to do that in this video. I'll do that in the next video when we talk about improving the cloth setup for this character. Next, we're going to add a point wrangle where we're going to add our string and our integer attributes. So in here I'll add an integer attribute that I used as a 1 or a 0 to declare if these points are part of a group. So I will call it integer undershirt equals 1. Then I will add a string attribute for the collision group, and I will call that undershirt. Each garment will have a point wrangle where we determine and declare certain string variables like collision group and whether something is part of a garment or not. Okay, let's add some default vellum cloth and get going here. So we'll do tab vellum cloth, configure cloth, point it in. For our collision object, we want to pull in our body, which is way over here. Collision all. So this is here. So we're going to pull that in over here. I use an object merge to keep the nodes from crisscrossing all over. There we go. So we have something to collide with. Next, we're going to put down a vellum constraint node. And in this node, we want to set it to pin to target. Pin to target forces the simmed points to try and obtain the unsimmed state. So if you have something enveloped or something that's in a limbic, it'll go to that state. It'll try and attempt to get to that state, and instead. Now let's put down a solver, and we will connect this up here. Now after the solver, we're going to put a vellum IO node. This allows us to cache our results to disk. This will allow us to test settings and test setups while we continue working. Let's go ahead and set the end frame here to RF end. That's our render frame end. There we go. Okay, let's set the default substeps to 5. Sometimes I set that back to 1 if I'm testing something that's not working properly. And let's go ahead and paint some areas that we would prefer stick close to the animation. In my early testing, I noticed that this area right here would kind of flap open, and I don't want that. I want to keep some sort of modesty, so I will paint this area here to stick closer to animation, though still solve. And we do that with our attribute. So there's an attribute I like to paint on this, and that is called animation. So we go here, and I'm just going to change mask to animation. We don't need mask, it's empty. And make sure you're painting animation here, and with a brush we will go down, and let's go ahead and start painting this. So use your scroll wheel, which I'm using a Wacom, so it's kind of a nightmare to do this sometimes. And what we'll do is we'll just paint this area here, and we will improve this. You will improve this over the course of your simulation if it's too strong, it's too much, or areas that you feel you want to keep. I like to just kind of put a little bit on the shoulders here, just a little dot here and there. And this just kind of keeps the shirt on the shoulders, and this works for dresses, etc. So I just like to put a little hidden dot in the background. Now let's right click and go to smooth. We'll just smooth out this area here. Again, I will improve this later. This is just for the basic setup notes. So basic setup, there will be areas of your cloth that you wish to follow animation to kind of stay where they are. Again, this will follow the unsimmed state, right? So there's these points in the animated remesh version of this. These values will transfer. They will be automatically transferred to your remesh, and they will want to follow the animated state. So the point deformed state, they will try and obtain that position in space. So let's go back down here, and on the vellum constraint, we know there's an attribute called animation now, generally right in here. So if we create points, a point group here, and we just say at animation is greater than 0.01, and you can see here where the points are blue, and on top of the gray mesh, that indicates points that qualify as being greater than 0.01. So what we want to do now is we want to change the pin to animation settings below, which are set as permanent, same as position and match animation. It locks everything. We'll change that to soft, soft, and match animation. So again, soft for pin type, orientation type is soft, and match animation is turned on. And this display is what you would see. It's not the greatest display, I don't think. I would like maybe a more colored, like using a colored visualize node instead of all these springs that we see here, are these primitives. But it doesn't matter, you can just turn it off. This just lets you know which points are going to be affected. So you just turn it on temporarily, look at it. I'm just going to leave everything as a default for this video, and we're just going to go ahead and try and sim a little bit here. So I set it substeps by default to 5. I just want to test it right now just to see if it's working, so I'm just going to set it back to 1, and we're just going to run, and then I just want to see that this area is generally following. So it's kind of draping down. You can see the area that's not draping down. is painted by our vellum constraint, our pin to target vellum constraint right here. And it should have a slight fall off here, and you can change the stiffness of that velcon, as you'll see in later videos that we use that. And the arms are moving down, so it is colliding properly. In order to test this, you can't just sit and wait for this to test. You've got to finish the other setup of your character. So that's what a vellum IO node is good for. So what we can do is we can name this properly. Whenever we run a sim, we're not clobbering the same old sim. As long as this is properly named, it should sim to disk. In here, I just pasted this in. What this should be called vellum IO, and then the name of the garment, undershirt. That's what it is. So this will be in the geo folder under undershirt, and it'll be called undershirt. And then you can just give it a version number here. I'm just going to go with version 1 because that's what we're working on right now. And once you have this in here, you can rewind. You can just send this off to the not to the farm, but you can be rendering this in the background. And the more RAM and CPU you have, the better it is to be working with this. So I'm going to go back to my solver. I know it's working right now for 1 substep, so I'm just going to change it to 5. I'm going to save my file, save as, and I'm going to save this one as in my scenes directory. We'll save this one as version 4. And with the vellum IO node selected, you can save to disk or save to disk in background. So what we'll do is we'll save to disk in background. Make sure you leave no operation as the current operation right here. It should be fine. This right here will open up your render scheduler. You can open it here by this, or you can close this out and you can open up another panel here. So I like to put the panel here. So I open up a new panel type, and then we're going to do render scheduler. So in the background, you can see I've just started solving this shirt in the background. And this frees you up so you can keep working and doing your setup. So this is the basic setup. Every one of the setups has all of these nodes in it. One last thing that it doesn't have is the outs here. So I create a solver for every piece, but when I merge all of these pieces, I don't necessarily want that. So one thing I like to do is I do a vellum pack, and this will be the last thing we do for this video. So we take our vellum constraints and our mesh, and we're going to pack it up, and we're going to call it something and give it an out. So we're going to add a null, and we're going to call this out undershirt. And that way I can test these individual garments, but when I want to share all of these garments in one giant sim with the belts and the top shirt, I can put all of these and merge them all using a vellum unpack, and then put those into a solver further on down the cell. So this is the basic setup. All of our garment setups will include these basic nodes and more. In the next video, we will continue on improving this shirt with some adaptive remeshing, maybe smoothing out some of these wrinkles on the sides I can see here that I don't like. Generally fixing any penetrations that might be occurring at the beginning of the sim. You can see that sort of on the wrist, there might be a few here. So let's go on to the next video.